here we have a question. F of alpha is equal to this. Show that f of alpha, the whole inverse, is equal to f of minus alpha. So to find f of alpha inverse, we have to check whether the determinant value is equal to 0 or not. So for cos alpha, for determinant value, you have plus sine alpha. Here you have 0, so that value will vanish. So sine alpha into 0 minus of minus plus sine alpha. So the value of determinant of f is cos squared alpha plus sine squared alpha, which is equal to 1. So that is not equal to 0. So f of alpha is non-singular. So f of alpha whole inverse exists. So now we have to find adjoint of f of alpha. So that is, now first start filling signs, plus, minus, plus, minus, plus, and here for cos alpha, the cofactor is cos alpha. For 0, that is 0. Here for sine alpha, you'll have this is 0 and this is sine alpha. So for here, this is cos squared alpha plus sine squared alpha. Here it is 0 again. Here minus sine alpha. Here it is 0. Here for the last value it is cos alpha. So the transpose of this is the adjoint of f. So we'll simplify it and write. So cos alpha 0, sine alpha, here 0, cos squared alpha plus sine squared alpha, here 0, minus sine alpha, 0, cos alpha. So transpose of this is adjoint of, so cos alpha 0 minus sine alpha. This column is converted into the row for finding the transpose. This column, the next column 0, the value of cos squared plus sine squared will become 1. So here it is 1, 0, and here sine alpha, the last column is sine alpha, 0, and cos alpha. So this is your adjoint of f. So now we have to find f of alpha, the whole inverse. So which is 1 by determinant value of f into adjoint of f of alpha. So 1 by determinant of f is again 1. So into adjoint of f is cos alpha 0 minus sine alpha, here 0, 1, 0, sine alpha, 0, cos alpha. So now we have to find f of minus alpha. So f of minus alpha is cos of minus alpha 0, sine of minus alpha, here 0, here it is 1, here it is 0 again, minus sine of minus alpha 0, cos of minus alpha. So we have to know one thing, that is cos of minus alpha is equal to cos alpha, because cos function is an even function. So cos of minus alpha is equal to cos alpha. Sine of minus alpha, sine function is an odd function. So minus sine of alpha. When you are having cos of minus alpha, the negative sign will not come. When you are having sine of minus alpha, the negative sign will exist. So now, f of minus alpha is, so Cos of minus alpha is cos alpha itself. So 0. Sine of minus alpha is minus sine alpha. So here 0, here 1, here 0. This is sine of alpha. Because this minus sign comes outside, so you will get minus into minus plus. So here 0 again. Here cos of alpha. So name this as 1 and name this as 2. So now here this is F inverse. So this is 1 and this is 2. So from 1 and 2 we have F of alpha the whole inverse is equal to F of minus alpha. So that's it. So this is for your homework. Try out the sum. A is equal to 5, 3 minus 1 minus 2. Show that A square minus 3A minus 7 I2. I2 means identity matrix of order 2 is equal to 0 matrix of order 2. That is 0, 0, 0, 0. So try out the sum for your homework, and that's for today's session. Thank you.